My talk today is about learning from incidents. My role is I look after an operations team. I do a lot of work with incidents, incident facilitation, postmortems, things like that. Over the last 2 years, as I've watched our organisation become incredibly more complex and increasing in complexity, is that learning from incidents is probably going to be one of the best things we can do to future-proof everything that we do. So this talk is a bit of a war story. There's some grabs I think most people identify with. Also a bit of theory and also what we did wrong, why we did it wrong, and how did we get better and what we hope the future will hold. So thank you for coming. So just a bit about Seek for those of you who don't know, which I'm guessing isn't too many people, hopefully. We've been around for 22 years. We're one of the little internet startups that could in Melbourne. We're still the #1 job site in Australia, and we're still headquartered in Melbourne as well, down on St Kilda Road. Almost all of our production workloads now run in the cloud, which is very different to where they were 6 years ago. Note I said almost, not all, and almost all are in AWS. We have about 160 accounts in AWS when I wrote this presentation. That's probably now about 180. That's kind of how fast we're growing with AWS. We can ship changes to production about 1,000 times per month. That's sort of an average. It really depends on, I guess, what we're doing at any point in time. The point is that we have the capability to do that. But a key theme about this talk is that things at Seek break. We are not infallible. We have production incidents. Things go offline. And one of the key messages I've been trying to drive at Seek is that we should expect this to happen. This is a normal part of what we do. And as complexity grows, it's not going to change. So it's our ability to adapt and sustain that adaptability that's going to see us through in the long run. So, quick overview. I'm going to go through when we were firefighters, when we didn't learn from any incidents at all. I'm going to go through how we poorly learned from incidents and how we thought we could learn from incidents. How we changed things, how we started actually seeing people in our systems as less as two separate entities, but more as a conjoined thing, like a proper socio-technical system. How supporting people is key to all of this. A couple of talks I've already mentioned things around psychological safety, that's crucial. And I'm also going to dovetail into a little bit about resilience engineering. So hopefully there's something that's for all of you, something you can take away from as well. So let's get into it. So about 6 years ago, Seek kind of looked like this. We had delivery teams that operated in silos, and we had operations teams that operated in silos, and they certainly didn't play well together. If you're on either side of that divide, you either wrote code or you deployed code with a pager. If you were an operations team like the one I work for, you saw every release as a hand grenade, setting your lovingly curated server pets on fire every release. This is pretty normal. Monitoring systems went crazy, and if you were customer service, you were probably in for a pretty torrid day when things went wrong. Then, when it came to incident learning, which is what we're all talking about, this is where the knowledge existed. Our delivery teams had absolutely no idea about learning from incidents. Half the time, they didn't even know if incidents were even actually happening. It would only depend on how loud and how vocal some operations teams got with them when things went wrong. So the rest of the Seek really had no idea. Our marketing people had no idea. Our executives generally had no idea as well. We weren't learning from this, and we weren't really understanding when things were broken. Turned out it happened quite a lot. Fast forward though into the year 2019, we kind of feel that for most part we've nailed this. We get it. We don't have a DevOps team. We used to. We got rid of that, thankfully. We see it as part of our culture. We see it as a set of practices that we encourage everyone who's in an engineering role to adopt. We don't favour using silos anymore. We like teams that own what they build through idea, through to execution in front of customers. We like to ship things regularly. We like the idea of deployment automation, moving as much manual and click-opsing steps as possible in a release process. And we also like a lot of autonomy in our team. So we generally have a rather diverse landscape of coding languages. We used to be a complete Windows C# shop about 6 years ago, but it is totally different now. And all of this is great, and I'm as guilty as anyone of sometimes standing at a conference and saying how awesome this is and how much faster we went and how much better, in terms of building our products we got. But there's one key thing about this, is that doing this made our environment much more complicated. And our ability to adapt and grow with that did not keep up with this complexity. So when we started out with a couple of teams. They built some services, they built some APIs. It worked really well. So then we said, well, that worked really well. Let's keep doing that. Let's build more and more of these, and then let's just keep building more and more of these because hey, this is a great model. We favour more autonomy. We favour people having own control. We like our own teams to do their own operational support and not leaving it in the hands of a single siloed operations team. But how we handled incidents started to change. And that is that the collective knowledge of handling an incident actually became much more localised in the teams, and it became more distributed. And so a key thing about this was, even though it was very localised and distributed, we weren't really sharing the learnings around. They all became little microcosms of incident learning. So it wasn't in a silo, which was a good thing, but we hadn't got rid of the inherent complexity of managing incidents. We just moved it around. We might be able to contain the blast radius of failure a little bit better, but ultimately the learning side of it, we weren't doing too well at all. And part of this complexity grew from the fact we had so many more integration points than we ever had. We had a mix of tight and loose couplings between different services. Some services can handle a bit of latency, can handle a few retries. Others were so tightly interwoven, if one broke, it would take out 3 or 4 more. So changes also became more unpredictable. We had localized decision making. We're just going to release, we're going to keep deploying. We're no longer having a change approval board or anything like that. Everyone should be able to keep changing time and time again. As long as behind interfaces, hopefully everything's working well. What this led to, though, is an interesting phenomenon that about 2 to 3 years of incident gathering has shown us, is that we're starting to see the concept of emergent behaviours. These are failures, or these are just behaviours that happen in a system that is now so distributed. And sometimes changes in different areas of the system can link up to create something that we couldn't foresee. We actually saw this happening about 2 years ago, almost around this time, was that in 1 month alone, we negatively impacted about 10,000 customers on our site, and we had a combined total of 18 hours of outage going through all the incident reports. For those of us like myself, thank you, Simon, I'm an old hand in the Melbourne tech scene, I did see this black swan event that was about to happen. And a lot of people in our operations teams were also worried something's really going wrong. Turns out we only had to wait a few months. So as Nicola put up the funny meme about DNS, yes, we had an issue with Windows DNS. Anyone here who's at Seek will refer to this as the great DNS outage of 2017. I know there are a few people in the room. But what effectively happened was Windows DNS used to work on our Windows servers in a data center. Windows DNS is usually pretty reliable and pretty robust because Windows caches DNS entries. In our haste to move into AWS, we just peered everything back to our data center production environment. So all of our AWS accounts and all the services, Linux boxes, whatever, were all reliant on this Windows DNS. And then when the WannaCry virus came along, we thought, why don't we upgrade our DNS service to Windows Server 2016? And that shipped with a bug. Recursive DNS lookups failed. The end result, we had a combined total of 12 hours of outage in one single day. We had teams frantically hard-coding DNS entries, and all of a sudden their services would come back, then others would come up, and an absolute torrent of retries from other services would take them offline again. So it became this hilarious war room where people were running in and out going, it's broken, it's dead. I'm still got PTSD from it. But anyway, we learned a lot. And our managing director at the time was pretty swift and to the point to his director reports. What the hell's going on? We've moved all this stuff in AWS, everything's awesome, and we've just had the worst day in Seek's history. This was worse than when we lost power in a data center. So the command really was get control of the situation. And so this is how control of situation initially became about. In the great tradition of rolling the proverbial downhill, we just said, we need to get control of incidents. We don't want to have incidents. We shouldn't have these kinds of problems. Or if we do, we should mitigate them. We instantiated incident post-mortem, so that was a good thing. But the way we conducted them was we favoured, let's just find the root cause. Let's find the root cause of the problem, neutralise that, the problem goes away. How do we find the root cause? Let's use the 5 whys analysis technique. We've all heard this technique before. It all sounds very, very common to a lot of us who've been doing this stuff for a long time. And even though, while we produce a lot of data from these investigative analysis, it was mostly lagging indicators, so we weren't learning anything from it, we were just reporting on statistics. What also made this not a great experience was the fact that we would ask questions like this of the people when they walked in the room, and we would assume things like this of our systems. In other words, what we were doing is we were applying a very, very liberal dosage of this. In other words, for the people who were sort of in a more senior role, it was almost like, why is what I have prescribed not what has actually happened? And why aren't you doing what I've prescribed is sort of the theme here. What made it worse was then we decided, well, we're going to review all the incidents every week just to make sure we've got a handle on things, and we'll give people a very localized action list of things to fix that we've pulled from it. We're not going to look at systemic issues. We're just going to neutralize these little hot spots, these little fires. We're going to be 5 people. We're going to run and put a fire out and put a fire out and put a fire out. And we're going to focus heavily on people. Because surely if people knew what they were doing, we wouldn't have had this problem, right? That's just how it should be. And when people came in, we'd generally frame conversations like this. In other words, we're prejudicing people before they come in that this is a human error issue. So as you can imagine, people walked in feeling like this and left feeling like this. What also compounded this situation, which masked itself as an actual success, was that several months, sometimes incidents went to 0. And a lot of people thought, oh, we mustn't be having incidents anymore, so our incident reporting for the month looks really awesome. The reality is some people were hiding incidents. And why wouldn't you? Do you really want to go to a meeting and get absolutely chewed out because something that was beyond your control or prescribed went wrong? This was being avoided. And we started noticing this on some other metrics that we were measuring at the time. Sometimes after a great month of perceived no incidents, it would take maybe an hour, sometimes maybe even 30 minutes. We'd say, everything's great, we did an awesome job this week, team. No, we didn't, actually. We still had incidents, and in some cases, things still went nuclear, going by the incident reports. What this all showed a lot of us at the time, or those that were researching it like myself, was that we weren't learning. And in the tradition of any awesome speaker, I'm just going to quote someone really famous who's also going to be absolutely ranting about this all over social media these days. He's an awesome person to follow, by the way. Very, very smart man and delves a lot into the theory on this. But the core thing is what we were doing wrong is we were seeing these things as two separate problems. We were seeing this as a people problem and generally prejudicing, or we were seeing it as just a system problem. Oh, this crappy old system doesn't work. It's crap. We shouldn't use it. I mean, even though millions of dollars of revenue throw for it, it's still crap. So why weren't we seeing things as a socio-technical problem? Why weren't we seeing the intimate rule actions? Why weren't we actually trying to understand why people did what they did when the pager went off? What were the triggers? What were the things that they had to do at the time? Why were all these sort of compensation routines enacted? What's the real cause behind that? Are we just assuming people are doing a crap job, or is there actually a really valid reason for this? And given that, over the broad part of a day or a month when we actually deploy things and everything go well, why are we focusing so heavily on what goes wrong all the time? And why aren't we promoting what we're doing well and keep doing more of that? So these were some of the questions I asked myself about 2 years ago when I was looking into all of this, because I wasn't seeing the change. And we were instantiating all this process. We'd made some gains in some areas, but in other cases it wasn't. And some people even to this day don't like coming to a weekly incident review because of their previous experiences over 2 years. So I started thinking about it, and I started thinking, is our way we deal with incidents heavily biased by the way we actually manage work? So for a bit of a history lesson, and I'm sure I'm not the first person at the conference to quote this gentleman who wrote this really famous publication prior to World War I. Taylor was an industrialist. He worked in a lot of factories. He employed scientific management principles in order to make people work better. So he favoured time in motion studies. He wanted to reduce everyone's work down to very simple, measurable scientific ways. In other words, he saw people as merely cogs in the machine, and we need to neutralise these kind of behaviours that we witness. And we should instantiate people in management to command and control us and to make sure that everything gets done. Despite the obviously dehumanising aspects of this, he was also a fan of eugenics, but let's not go there. One thing though was his publication was very successful, and a lot of industries took it up and also saw results in terms of increased output and more profit. But the one thing Taylor was trying to do with all of this, and I'm not going to pretend to be an expert, is that this whole notion of what I have prescribed is what I'm telling you to do. And I want to know from the top level down what is being prescribed is what is being done, because that's predictable, it's risk averse, and I know what's going on. So myself, both my grandparents worked in factories. They're used to assembly lines. They would tell me about punch clocks. They'd tell me about working on conveyor belts. One was in Belfast, one worked in Moorabbin down the road in Melbourne. And I thought, that just sounds crazy. Surely time in motion, that's just crap, isn't it? When I started out my career in the late 90s as a dev, this is how I was measured. Very much time in motion studies? How many lines of code do you write per day? Why couldn't you write more? You're only doing this much. Then I also thought, why do we do this waterfall stuff? Why is this so linear? And why are we going through all these really prescribed processes just to push a small code change out to production? A lot of this is all based on the concept of linear thinking, which works fine for an assembly line. But what we do nowadays is not linear. It's very complex. It's nothing like early 20th century manufacturing. And so I thought, well, what has this got to do with incidents? Well, when we think about when we deal with incidents and the way Seek was doing it was we were seeing it as a chain of events. The falling dominoes theory or the Swiss cheese model of how things go wrong. So of course, we're going to prioritise isolating it down to a single cause of failure. And we're going to be heavily influenced by seeing a one-to-one relationship between a cause and an effect. And more often than not, we're going to presume it's the humans, because if the humans just did what they were told and how I prescribed it, nothing will go wrong, right? Because what I've produced is so fantastic. Thankfully, Toyota actually brought the human back into a lot of this stuff with the Toyota production method that was conceived in the 1950s, much more at work in time, work in process, actually giving the actual workers control over the system. But Toyota actually was the one that advocated the 5 whys and root cause analysis as well. So for a lot of our thinking, the way we thought we'd deal with incidents was heavily influenced by this, even though if we didn't really probably realise at the time. Myself included, I just did it because that's just how everyone came before me did it, and I just assumed that's what we would do. So, 60 years later, this is what modern complexity looks like at Seek. As I talk to you right now, we have over 1,500 EC2 instances running. We have over 1,000 Lambdas that I'm aware of. We have over 200 RDS databases in AWS, and we have over 4,500 S3 buckets alone right now. We are actually probably about 180 to 200 AWS accounts by now. We have 2,000 GitHub repos, and we have over 30 teams dealing with this. Keep in mind that this is a combined total of about, I'm going to say, 300 to 350 people just in Melbourne working on this. And this is just based on Melbourne. So that's a lot of stuff going on. A lot of the ways in which things communicate is API or event-driven. Mix of loose or tight couplings depending on how they are built. It also means then that changes are very unpredictable because of localized decision making, and it often means we don't even know all the integrations. I've facilitated many incident postmortems where some teams have come going, I had no idea you were using my service. And we're like, well, but this is the world that we live in now, and we gotta kind of expect this even more and more. So, with all this complexity in mind, why does root cause analysis fail to learn about complex systems? This is a simple example. You've got the customer up there on the left and all these little green blobs. Think of them either as services, some feature, some process, whatever you want to call it. This is a pretty standard way information gets in front of a customer. It usually comes from lots of different sources. It gets massaged, it gets changed, and ultimately it flows back up into something they can see on their device. Now, at any one point in time, we can assume that sometimes things aren't performing at an optimal level. That's normal, that happens. Sometimes those changes push up through the call stack. Again, that's normal and that happens. The whole system overall handles it. Latency, redundancy, it's built in and it deals with it. But then say, for example, we're having a bad day. Say one team is deploying and the deployment's not working well and they're rolling back. So there's this interim period where requests are really slowing down. Another team might have pushed out a change that actually influenced a couple of other teams on a dependent service. Again, perfectly normal. The system copes. But then the system stops starting to cope. Failure starts to push up through. Eventually things go red. Then more things get overwhelmed. And ultimately, kaboom, we have an incident. And the customer's experienced something wrong. Maybe a gateway timeout. Maybe they're trying to apply for a job and nothing's happening. Or something simple like that. Now, if I was to take the 5 whys analysis, I would start here. I'd go here. I go here. I go here. And I'd probably end up here. And I go, ta-da! That's the problem, people. It's there. That's the problem. So the next time I have that incident, I'm probably going to use my recency bias, and I'm going to go, no, it's definitely that team. We actually have a device at Seek. It's a layer 7 device, those authentication tokens, and many times we had incidents, and we go, is it layer 7 the problem? For a joke, one of our engineers actually had the domain islayer7theproblem.com, and it would just return yes, right, for a joke. But it was like, but the point we were trying to make is that don't bias your thinking, because what about these factors here as well? If we constantly follow 5 whys and root cause analysis for every time we have an incident, we are going to miss this stuff. We're not going to learn as much as we could from it. So just with this theory in mind alone, this is what we observe. One, Localized management is happening the greater the complexity grows. That's just a byproduct. That's what's happening. We know our systems evolve independently. They're not assembly lines, so don't think of them like assembly lines. And lastly, trying to maintain this Taylorist horror is not going to work either. There is no point trying to document everything that we do. It'll be out of date before we know it. So don't try and do that. So how do we get better at incidents? One of the ways to improve, definitely, we want to look at our systems, we want to have the right metrics, we don't want vanity metrics. But the other part is understanding our people and understanding the pressure our people get put on a day-to-day basis, both before, during, and after an incident. Because they will be experiencing different feelings. They will be under certain pressures. And how are they feeling afterwards? If someone's been up for the last 3 nights trying to deal with an issue, which actually one member of my team was doing through to AWS having a network card issue, we don't really want to drag them in at 8 o'clock the next day and go, why did this go wrong? They're usually probably going to be in a shitty mood and they're probably not going to want to talk about it just yet. The other thing too is, what is a culture like in our teams? Andrew spoke about this earlier about culture, and he's spot on. Culture is so important, not just in an organisation, but in your teams as well. If you have a culture of shoot the messenger or bury the messenger, you're probably not going to learn a lot out of this when things go wrong. If it's an embracing culture, probably a lot more. If some of you are thinking, where have I heard this before? You're right, I just literally swiped this from Westrum's organisational culture classification, but I've seen it happen in teams as well. And generally the teams on the left side of that generally don't learn as well from incidents and generally don't exhibit the best behaviours when they go on as well. So as leaders, this is really important stuff. If you're managing engineers and they're on call, we've got to be mindful of these kind of scenarios. So the next stage, doing it well, is the post-mortem. Post-mortems are not about blames or pointing fingers, and they're not about witch hunts, so don't do that. It's not about that at all. First and foremost, it is about supporting the people who've just probably been through a really crappy experience and have been up all hours of the night. So what we want to do, focus on contributing factors. Build out some timelines. Try and make this an actual conversation where you're trying to explore all the different avenues. You may want to do this in one-on-one meetings, or you may want to facilitate it broadly. And when you want to facilitate it broadly, focus on not just the system or not just the human. Look at the customer. Look at the interactions between all of this. Try and learn as much as you can. When you're facilitating an incident, one of the things that has worked well for Seek is we have generally 2 people. We have the facilitator and we have the scribe. The facilitator is generally someone who has a technical background. They understand what it's like to be a software engineer. They understand the tech stack to some degree. This means then they can have more meaningful conversations with the people that are turning up to the post-mortem. Our scribes are what we call our service management team at Seek. Almost all of them actually come from customer service. So they know the customer journey really, really well, so they can often interject with other sides of the equation. And when we're building the data, we're not just focused on leading indicators, we should be focusing, lagging indicators, we're focusing on the leading indicators. What are the patterns that we're observing? Are we having systemic issues in certain areas, and do we need to focus better efforts on there so the same situations don't keep repeating and playing out time and time again? Even just by doing these simple changes, these are some of the things we've noticed. One, the way we think about resiliency has improved a lot. I'm quite amazed when I look at a lot of the incidents, just the amount of circuit breakers and the amount of thinking a lot of our engineers put into things now than they ever used to before. We ship with a lot more confidence. Generally, the things that we build are generally a lot more reliable than they ever were before. So we're seeing these benefits coming from this change in mindset. We've established what we call at Seek a paved road team and other teams, and we're looking at building out more common services. A lot of this have come from actually looking at when we've had incidents. Classic cases being around edge networking, where we used to have teams that would do a lot of routing on their own. We've now centralised that. We centralised logging of information, so we stop having all these disparate sources of information. But one of the best things, some of the best feedback I've ever got from all of this is people actually saying to me privately, I don't feel like I'm being put under a microscope anymore. I don't feel like I'm coming to this feeling like I'm going to be made to feel bad for something that went wrong. I didn't mean for things to go wrong. I didn't turn up today to do a bad job. You know, I just want to learn from this too. I want us all to learn, and hopefully I'm not wasting all my time trying to support things and not getting the support I need to improve the technical health of my systems. The other win, and I'm not saying incident learnings has come from this, is the old sacred cow systems, the ones that no one want to touch and destroy because they break all the time, are being actively destroyed at Seek. As of yesterday, we terminated our agreement with our data center provider. We no longer outsource our data center anymore. our old deployment tool, this piece of crap, has finally stopped working. We're actively replacing it. We're starting to see the value of this. People are not afraid to go in and start changing a lot of crap that no one dared touch because they were worried it was going to break. We have gotten rid of that fear, and we're seeing much more innovative solutions in dealing with it, which is something I'm at least going to take as a partial win. So, just by doing this, just by instantiating these practices, we've come to appreciate complexity does not decrease. It's not going to decrease, it's going to keep increasing as the business grows. We know that feedback loops for the things that we build are going to be unintended. So we need to accept the fact that emergent incidents are going to be a reality. We're going to be able to learn from them, but they are going to happen more and more. This is a natural byproduct of a complex system. We also appreciate that the people that we have are the flexible and adaptable parts of the system. And therefore, we should be creating environments for them, and we should be trusting and supporting them while doing so. We want to really think about team health and culture, especially when we have operational responsibilities. And we want to see incidents as learning tools. We want to know that, hey, you know what, we can actually benefit from this. We can learn more from incidents, as much the same way as chaos engineering or site reliability engineering is helping us prove the resiliency of systems. Incidents can do that too. And if we can all do that really, really well, we may finally be talking a lot more about this stuff in the future. I don't proclaim to be a resilience engineering expert. What I will tell you is you can generally think of it in these 3 words. It is your ability to build software systems and build products for your customers that can sustain the capacity to adapt to foreseen and unforeseen events. Resilience engineering is a field and it's a community. The origins come in multiple disciplines, and it's only relatively new to IT, at least as best I can tell. It's been around in other industries like aviation, healthcare, chemical plant manufacturing, nuclear power for much longer still. But the key point to think about resilience engineering, it's about what you do. It's not what you have. You don't just get it off the shelf. It's a practice. It's things that you are doing on a day-to-day basis. And for those of us who are leaders of tech teams, we want to be thinking along these lines. To understand it, what I will tell you, it's not a tool, it's not a process, and it's not a fancy management consultant. It's none of those things. There are examples in nature, they exist everywhere. Despite the fact that half of them are probably on fire at the moment, and I don't mean to be flippant about that, I know what bushfires are like, is that our gum trees are actually pretty resilient organisms. They are flood, fire, and drought proof. Our own skeletons are quite resilient as well. We regenerate our bones every 10 years or so. They can cope and adapt with lots of different things. But the key point about resiliency, nature gives you great examples of it, but gum trees don't jump up and run away when a chainsaw comes at them. So for us, when we're building these much more complex systems that we are doing over time, we need to be able to adapt to these unforeseen events, and we need to be proactively thinking about how we sustain that in the long term. If we do all that well, ultimately, we're not going to wait for it to go naturally. We'll be making an ongoing practice. We will know that we can create conditions where our teams can sustain that, wherever the work is being done, not where it's being prescribed. We'll learn from incidents as much as possible. We will see them as natural byproducts of complex systems. Well, I said right at the start, stuff breaks and we should expect it to. So let's learn from it as best we can. We should understand the intimate relations between people and tech. Don't isolate them as separate challenges during an incident. Try and understand why people did what they did when things were going wrong. And lastly, if anyone has looked into Safety 2 thinking, great. If you haven't, I would strongly encourage you to do this. Focus and promote on what you do well and grow a learning culture. Learning cultures are one of the best bets for our organisations to succeed and for us all to hopefully stay employed and have good working lives. So I'd like to say thanks very much for your time. You can access this presentation at that URL because I hate PowerPoint, so I'd just rather you just get it now and not wait. And if you would like, please reach out to me on social media. Thank you very much. Cheers.